All right, guys, I think I finally hit my stride on working through these work pieces here. Thought I would get a little video to show you. I've got a little bit better system of getting the blocks in and out of here. And now that I know exactly what I need to do, I got my feeds and speeds dialed in where I need to be. I've got our indicating set up the way I need to be. Getting this piece in and out properly without having to flip it. I've got that figured out. So we're gonna get a little video of that, showing you get one in there. It's about 10 to 15 minutes once I finish one, getting it out of the machine, getting another one in the machine, getting everything done and ready to drill. So I've already got this one indicated. So as stated before, after I finish the bore, I put my collet chuck in here, coax indicator, already got it centered. I got my dial indicators and dials on 0 over here. So now we're ready to drill. So I'm gonna go ahead and get this one out, get the next one put in. So I've got the next two staged over there on the skyhook cart. So I take it out of the lathe in this position right here. We're gonna set this onto the cart in this position and grab the next one just like you see here, go straight into the lathe like that. This is going to be our final pass. I've got 32 thousandths to take out of that. This is what I'm talking about. You can see that it tries to pack up a little bit, but it doesn't seem to be affecting me on my finish. So let's see if I hit my target. So my target is 3.347 to 348, but I'm actually trying to hit closer to the 348 because that's allowing more of a slit fit, which is what they want. So this one I split it. Close. So 347 and 7/10 on that measurement there. So that's perfect. Right where it needs to be. Same thing, 347 and 7/10. So I'm within that 1,000 that I want to be, but I'm on the high side, which is preferred because at that point I can actually take that, and once I get it lined up, it'll slide in there. When it's closer to the 347, it's trying to go, but it's so close that you would have to kind of tap a little bit, and you don't want to do that and get it stuck in there. So doing well, doing good. This is number 5. Got 10 more to go after this one here. I'm gonna chamfer that edge. All right, so now we're at the point of, we want to go ahead and get this bore indicated so we can recenter our drill. And once we do that, this will be coming out and replacing it with the next workpiece. What I've been doing to get it close is I'm running the tailstock up and just kind of eyeballing the back of this collet chuck. Something like that, just get it close. And then we can run this in here and go ahead and get it centered. Within a 1/2 thousandths right there. Go ahead and get my dial indicator set here to a 0. Reset the collar on the cross slide to 0. And this one's still on 0. So we're ready to set up the next piece and repeat. All right, guys, I thought I'd give you a mid-job progress report. I'm down to my final 3 blocks. Everything is going great, just as planned. I finally got a really nice rhythm going, minimal movements, getting them in and out of the machine. I've got my drilling speeds and feeds dialed in. I got my boring feeds and speeds dialed in, and everything is working great. So I just kind of want to show you where I'm at and what we got left to work on here. So we just finished this one. I've already got it centered. I've already got this centered on there. We got our magnet ready to get it out of the machine. And I just wanted to give you an update before I load up the next batch of 3. The Skyhook cart has been working awesome for this job right there. I don't recall if I mentioned it earlier, but I installed the dual handles on this thing, and it has made a huge difference on loading and unloading with that. It just balances the load when you're using both hands at the same time. So Skyhook has been working great. These 3 I just finished today there, just finished the 4th one, getting ready to load up another one and start on that. Now these 2 right here, I've got these set to the side because both of these finished 4 to 5 tenths under what I wanted them to finish at. It's right at what you would consider an interference fit. So it's a little too tight. They want the spindle to be able to slide in. So I've actually got some flaps on order, probably gonna be a couple more days before they get here, but I was just gonna wait till the end, and what I'll do is I'll set these guys back up in the chuck, get them centered so that I can just spin them, and I'll have those laps. I'm probably gonna have to machine a little extension for the die grinder, and I'd like to go in there and just see if I can just flap or lap those guys out, get about a 1/2 thousandths out of those bores. Hopefully we won't have a third, but if we do, it'll be right here, and we'll take care of those last. Here's the other ones that we've already got finished up. There's one more right here. This guy is finished up, so those are the final 3 right there. I'm getting ready to load those up on the Skyhook cart and get started on them, and hopefully in about another day's worth of labor, I should have this job finished up. So like I said, I just wanted to give you kind of a report on how things were going. I've been really happy with the drill. It's worked great. I'm still using the original blade, you know, the Spade insert that we started with, and it's still working fine. Every time I drill a hole, I inspect it. I don't see any burnt edges. I'm not hearing any abnormal noises whenever we're running it in the machine. This pacemaker is sounding beautiful whenever it's making that cut. Everything is working as planned. So I'm going to keep working through these guys, and I'll kind of, whenever we get to the flapping, I'll give you a little update on that. But otherwise, we're getting near the end of this job here. Number 15, our final block to drill and bore. This is the one I've been looking for. I've got to say I've been real happy with the performance of everything, including our American Pacemaker. It's been handling this heavy duty work like a champ. Our Allied machine spade drill has been working perfectly. I still have the original insert in there. I haven't swapped it over to my backup. Every time I drill a hole, I pull the drill out and I inspect it, and the drill looks like it's still in perfect condition. So we've been continuing to use it. We're gonna have this chip pan full right here. Look at that. So excited to see number 15. I still have the 2 blocks sitting over there that we're gonna put back in here. We're gonna do a little polishing and honing on. And I believe my flap should arrive today, either today or tomorrow. They should be here. And I think over the weekend, I should be able to have this job completely wrapped up and finished. But real happy to see it come to the end. nearing the end anyway, and everything has been working out great. This has been my cozy little spot all week long while we're watching the drill do its thing, watching the bore and bar. I got my speaker up there, been jamming some tunes. Got the AC up there blowing some cold air on me. It feels good. And just listening to the pacemaker work its magic. It sounds really good from here. Here's a look at our 3 1/4 AME spade drill. After drilling 15 of these blocks, a total of 120 inches depth that was drilled. Our insert looks to be in good condition still. It's been working just like it's designed to. Got a bed full of chips there. Got this chip pan filled up. Really happy with the performance of our spade drill there. It's worked great. Block number 15, the one that we've been looking for, it's complete. I got my flap wheels in that I ordered from KBC Tools. Thought I would show you what we're going to be using here. So I got a couple of these guys ordered. This is 240 grit, Superior abrasives. This is called a flap mop. It's a little bit more forgiving there, kind of compresses a little bit easier. I'd like to give this one a try and see if it's going to work. But I got these as well, so these are more coarse. These are 60 grit. And just in case I needed a little more cut power to try to get that bore polished out, because sometimes even trying to polish a 1/2 thousandths out of a bore can be a little time consuming, a little bit difficult. So I want to make sure I had something a little more aggressive on hand just in case these other guys didn't work. But I did polish the first block with success. It worked really good. I already had these wheels here. I got these from KBC as well. These are called the SureBright mounted duplex wheel. So it has a combination of your emery paper and your Scotch-Brite in there, so it does a good job of cutting and polishing at the same time. This is the one that I used right there. All right, but it's only 1 inch wide, and that's why I went ahead and ordered these guys, because you have 2 inches of width there. It gives you more support inside the bore. So I want to see if I can get the job done with these guys right here. So down to the final 2 blocks. Let's go ahead and get them polished, get this job finished up. He got about 3/10 out that time, so I definitely got a little more polishing to do. You know, taking measurements with a telescope gauge and a micrometer wearing these gloves is going to bring all kind of negative criticism to the comments. It's just one of those things you know going into it. Looks like I got a couple more tenths out of it. I'm just about there on our bore. That flap's doing a good job. Okay, I feel good about where we're getting this, but I really love the performance of this duplex wheel, so I'm going to go ahead and finish it with this one. I think we're going to be real close here. We can get a couple more measurements on this one. Gloves off this time. I'm at 6/10 over right there, which is right on the bottom of where it needs to be, the smallest that it needs to be, should I say. Get back in there a little bit further. And I got 6/10 back there as well. I think I'm going to go in there just a little bit more with this duplex wheel. I think I can get a couple more tenths out of it, this right here. I want to say though, you know, I going into this YouTube stuff, doing video and social media, it's always a way to realize there's things that you do that really bothers other people, you know. And for 12 years now, showing a telescope gauge and a micrometer really seems to bring a lot of controversy. I have been using these my entire career. My dad taught me how to use these. This is what he used. And I've literally used these thousands of times to measure a bore for all different kinds of jobs. And it's always been accurate. It's always given me good results. The trick is you got to have good quality telescope gauges. That's why I like using Starrett, because they are the best. Number 229 from Starrett. I like the single leg. That's the ones I prefer. And I like the pivot on the bottom when I pivot it out. You got to learn how to have the right feel, the right touch when you're rocking it. You want it to where it just touches. Just enough friction where I think I've showed it where the telescope gauge is kind of captured between the anvils there, but not tight. Just enough friction that it holds it and you can just easily knock it out. That's going to give you accurate results every single time. This is what I've always used. This is what I'm going to continue to use. It's interesting how it bothers people when one person prefers to do something another way, next person prefers to do something completely different. What I'm usually hearing is, why don't you use a bore gauge? I always use a bore gauge. I just use a bore gauge. That's not accurate. You can't get good readings with a telescope gauge, but I always have, and it's got me good results. But I actually don't own a bore gauge. I never have. Just never used a bore gauge and never had one. I think it's something that I am going to add to the arsenal and start using it and practicing with it. But For right now, I don't have one, so I'm going to keep using my Starrett mic and telescope gauge to get the job done with excellent results every time. Give it another check. I think it may be there, maybe right where I want to be. I do that just to make sure there's no dust that settle on the surface that I'm trying to measure there. So you just got to get the right angle there. You don't want to be too steep. Get it in the center, so you just kind of rock it a little bit, get it in the center, snug it, don't tighten it, just snug it. And I like to hold my right hand underneath it to catch it and push down with my left thumb and pivot on the bottom, just like that. Now that actually touched, the top one came down and touched, so you really need to redo it there. But I'm gonna go ahead and check my measurement and see where it's at. It's looking right where it needs to be. I'm gonna go ahead and do that again. A little easier just to do it instead of talk about it. Catch it with my fingers just like that. Put it on this bottom piece here, or that side of the telescope gauge, right on the anvil. And I'm using my middle finger and my thumb to hold it in the center of the mic, like that. And you want to rock it back and forth until it just touches. Just use your finger here to adjust the mic. Very, very small movements. And you just want to rock it back and forth until you feel that touch. You see how it's just holding it in there? Just like that. Don't get discouraged if you don't feel like you're getting good readings. It takes practice. I didn't do this in a day. You know, it took me a while to get comfortable with this and develop my own techniques and feel. My dad didn't tell me how to do like I showed you right here. I just developed my own technique on using a telescope gauge and what works for me. I'm going to check that one more time. And now we are at 0.8. I think the bearings are going to fit in there just like I want to now, so I'm going to go ahead and grab that spindle and we'll give it a test fit. Blow the dust off of it. Let's just go with it. It is extremely close, so you just got to be careful here because you can see it's going in there. And that's as far as I'm going to take it right there. I know it's good. It's going to slide all the way in there. I've been checking all of them like that, but it does make me really nervous sliding it all the way into these bearings here, just in case it gets caught or something. I don't really have a good way of getting it out of there at that point. So I leave it right here so that if it does get tight, I can take a punch and tap on it. It'll kind of move it out of there. But you can see we've got a good fit. This is what the customer asked for. They did not want to have to press this in there. They want it just loose enough where it'll actually just slide in place. You can see what I'm talking about right here. Such a close fit. If you're hitting it too hard and pulling on it too hard, it actually gets bound up. Just like that right there. So since this one is on size and it's ready to go, that means that all 15 are now finished. Only thing left to do is we'll get this one out of the machine. I got to get it on the pallet, and I'll meet you guys over there. We'll have some final words of this job, okay? Well, there they are, all 15 of them completed and ready to go back to the customer. They're all on size. I checked all 15 of them with the bearings. They all fit just like they're supposed to. They're all machined within the specs that the customer requested, and we decided to machine them to. A very light slit fit on the bearings. These guys are ready to go. Quick reminder, these are not completed yet, so Donald, Iron Eagle Machine, that's who I'm doing this job for. I'm just helping him with the bore here, which we've done, and he's going to set these back up. I think he's got a Haas. I don't remember what machine it is, but he's going to finish machining these to a completion in his shop out in Colorado. So we're going to get these guys ready to go, get them strapped up. I am going to get some rust inhibitor spray on there just to protect them from the transit from Florida out to Colorado, make sure they don't start rusting. I want to make sure all the bores are safe. They don't get flash rusting in there. So we'll do that next, and then we just got to get them strapped up, ready to go. This is what I'll be using, our CRC SP350. Really great corrosion inhibitor. I'm going to give them a really good just dusting all over the outside. Get it up inside the bore there as well. I just want to be sure that we don't get any flash rusting in these before they get to the customer. So I'll go around them and get them covered completely. Well guys, that is going to wrap up this job. We are finished with it. All the thing left to do is just to get it strapped down to the pallet here and get them shipped out. But you know, this has been a great job, not only for me in my shop, but I think to share on the channel here as well. You know, all the videos that we created to show us the journey of getting our American Pacemaker flood coolant system back in operation. It's not 100% perfect, but it works, and it worked well, and it did exactly what I needed it to do for this job right here. That was my first time running a large spade drill like that, and our AME spade drill did a fantastic job drilling these guys out, and I couldn't be happier with the results. You know, we had those 3 that I had to do a little bit of polishing on. I had to take a 1/2 thousandths out of it, and it wasn't any problem at all. We got them all on size, gave the customer the fit that they wanted to, and I am happy with it. It was a great job to prove the reliability and the performance of that old lathe, that old American Pacemaker that was made back in 1942. I think it handled the drill great. We had quite a few people that shared their concerns that that tool post was not going to work, the setup wasn't going to work, it wasn't rigid enough to hold a drill that size and do the drilling. And I knew in my mind that that lathe could handle it, that all the components together could handle the job. And I proved that it did, and it worked out great. Real happy with how the machine handled the drilling. And I couldn't be happier, honestly. So it was a pleasure helping out Donald at Iron Eagle Machine with this job. You know, I kind of appreciate him reaching out to me. And this is something that we've actually been discussing for quite some time, several months. That we've been discussing, and he took some time to get them roughed in and left them the shape that we left them here so that I could chuck them in the 4-jaw chuck to do the drilling and boring. And now that this is done, he can set them back up, and there's a lot of material that gets milled off these things. It's sort of a weird shaped piece, but customer asked not to talk about what they're for, what their intentions are for these parts. And that's very common in industry. You know, we're lucky that we get to share a lot of this work on the channels with everybody, but it's not often that we get to talk about the end product or what it goes to, where it's used in industry. Sometimes it's proprietary, and sometimes people don't want that information out there in the public knowing what their business is, you know. But showing the drilling, showing the boring, how we're setting it up, indicating all that stuff, that's all fine. You know, it's okay to share that kind of things, and I was happy to be able to do that. And hopefully the people that are watching the channel that are here to learn and pick up some tips and tricks and techniques on manual machining and indicating and drilling and boring, hopefully it was informative to you guys. If you're not here to learn, you just want some entertainment, hopefully you were entertained with this job there as well. I was happy to share it with you, and I hope you guys all enjoyed it. So I'm going to sign off, finish getting this guy strapped up, and get them on out of here. I hope you enjoyed the videos. I hope you enjoyed all the videos, and I hope you come back for the next project. All right, see you guys then.